This is Advanced Math, Set 90, Double Angle Identities and Half Angle Identities. So this lesson is really kind of just like the lesson we had just the other day. I think it was lesson, lesson 89, where you're just kind of playing around with the trig functions and you're trying to find some new identities just by manipulation of the trig functions that you already have. So the first thing that we're going to do, sorry, I'm just double checking. Yeah, that was lesson 87. So the first thing that we're going to do is just recall the trig functions that we already are aware of, the ones that you need to be memorizing. So that we'll just start out. Sine of a plus b is sine a cosine b plus cosine a sine b. Sine of a minus b is sine a cosine b minus cosine a sine b. And then when we're adding for cosine, remember cosine is cosine, cosine, sine, sine. So it's cosine a cosine b minus sine a sine b. And then when we have cosine, we do the opposite operation. So if it's a minus b, we're going to do plus. So it's cosine a cosine b plus sine a sine b. Then we just need to remember the tangent of theta is equal to sine of theta over cosine theta. And then the other thing that we will need for this lesson is the knowledge that sine squared theta plus cosine squared theta equals 1. Okay, so this says develop the identity for first sine of 2a and secondly cosine of 2a. So we start out with what we know. We know that sine of a plus b is sine a cosine b plus cosine a sine b. And now we need to see if we can figure out how to manipulate this piece of it into something that looks like this. So we can do it pretty easily if we say sine a plus a, because a plus a is going to be 2a. So instead of having a and b, now we're just going to have a and a. So we'll just replace everything. Sine a, cosine a, sine a. And if we do that, you'll notice that you've got, if you just use the commutative property and switch them around, you've got 2 cosine a, sine a's. Or you could have switched around and say sine a, cosine a, either way. So there's our identity for sine of 2a. It's just 2 cosine a, sine a. So now we'll do the same thing for cosine 2a. So here's the identity for cosine of a plus b. We're going to switch it and say cosine of a plus a, and then we'll just plug a's in for everything. Cosine a minus sine a sine a. So this is a little bit different than what we had before. Here we have a cosine a times a cosine a, so that's going to give us cosine squared a, and then sine a times sine a is sine squared a. So here are your two identities, one for sine 2a and one for cosine 2a. So now we have two other pieces that we can use with our puzzle. Okay, so now we're going to use the knowledge that, let me go back. Okay, sine squared a plus cosine squared a is equal to 1. And now we know if we want to solve for sine squared a, we can say sine squared a is the same as 1 minus cosine squared a. So we're just going to kind of manipulate this cosine 2a a little bit. We just figured that cosine 2a is cosine squared a minus sine squared a. And then if we take that sine squared a and we plug in 1 minus cosine squared a in its place, so this is coming in right here in place of sine squared a, then we come up with cosine squared a minus 1 plus cosine squared a, so we get 2 cosine squared a minus 1. So there is another identity for cosine 2a. Okay, so this says begin with the identities for sine a plus b and cosine a plus b and develop the identity for tangent 2a. So we're going to take what we just learned and go from there. So let's go back, and we have sine a plus b. We know sine a plus b is sine a cosine a plus cosine b sine b. So we figured out that sine of 2a is 2 sine a cosine a. And really, you can kind of just look at it. Let me see. This actually is not right what I have written here. I'm going to have to go back and fix that. So this should be sine a cosine b. Let's see. So we'll trade that and make it a cosine b. And then this should be cosine a sine b. Okay, so now if we really just look at this and we want to do a plus a, if we plugged a in for everything, so if this became a and this became a, just by looking at it without having to work it out, you can see that you've got two of the same thing. So you can see that you have 2 sine a cosine a's. So let's move on to the next piece. Same thing, if we have cosine of a plus b, it's cosine a cosine b minus sine a sine b. And then if we plug in a for everything, so if we just think a and a, then without even have to work out anything really, we can come up with cosine of 2a, which is cosine squared a minus sine squared a. So that's what we've done so far, and now we're going to try and take that information and find the identity for tangent 2a. So tangent 2a, remember tangent is sine over cosine, so if tangent of 2a, if you have tangent of 2a, then you'll have sine of 2a over cosine 2a. Well, we have information for sine of 2a and cosine 2a, so we can just take that information that we have. Sine 2a is 2 sine a cosine a, and cosine 2a is cosine squared a minus sine squared a. Now, we need an identity, which means we need a 1. We need a 1 somewhere. So what we're going to do is we're going to divide everything by cosine squared a. So we divide cosine squared a by cosine squared a, sine squared a by cosine squared a, and 2 sine a cosine a by cosine 2a. So the first thing I can see is cosine 2a divided by, cosine squared a over cosine squared a is going to be 1. And then I have sine squared a over cosine squared a, that is going to be tangent squared a. And then on the top, I can cancel out the cosines. I can cancel out one of the cosines here and this cosine here. I'm going to be left with 1 cosine on the bottom. So I get 2 sine a over cosine a. I can cancel that out and make it tangent a. So if I rewrite this whole thing, because it's kind of messy, I have 2 tangent a on the top and 1 minus tangent squared a on the bottom. And there's our identity for tangent 2a. So all of that is equal to tangent 2a. Okay. Develop the identities for sine 1/2 x and cosine 1/2 x. So the first part we doubled. Now we're going back and we're taking half of our identity. So we'll start at the beginning. Cosine a plus b is cosine a cosine b minus sine a sine b. And we know cosine 2a, again, remember if you plug a's in for everything, you get cosine squared a minus sine squared a. And we know sine squared a plus cosine squared a equals 1. So cosine squared a is equal to 1 minus sine squared a. It's just rearranging that. Now I realize that it's just kind of throwing a lot of information at you, and I would not expect you to be able to pull all of this information out of your head and just be able to do it. This is kind of a guided activity. So it's like you're taking the pieces that I give you and then rearranging it. I'm kind of like giving you the scaffolding you need to come up with the answers. So we can also solve sine squared A, and we know sine squared A is equal to 1 minus cosine squared A. So we know that cosine 2A is the same as cosine squared A up here, which is this piece here. Okay, so cosine 2A is equal to 1 minus sine squared A, and then we're just going to finish it with minus sine squared A. And then solve from there, so we end up having 1 minus 2 sine squared A. And then we can do the same thing, but now instead of substituting for cosine, we'll substitute for sine. So cosine 2A is cosine squared A, and now we're going to do the same thing. We're going to substitute sine squared A with this piece here. Plug it in here. So we end up with cosine 2A is equal to cosine squared A minus 1 minus cosine squared A. So from here, we are going to simplify that, and we end up with 2 cosine squared A minus 1. Because you have a double negative there, so it makes it 2 cosine squared A minus 1. So we have two different equations that are both equal to cosine 2A. Okay, so now for cosine 2A, I'm going to solve this for 2 sine squared A. So if I solve that for 2 sine squared A, I would add 2 sine squared A to both sides and then subtract cosine 2A from both sides, so I get 1 minus cosine 2A. And then to get sine squared A by itself, divide everything by 2. So sine squared A is the same thing as 1 minus cosine 2A over 2. We're going to do the same thing over on the other side. We're going to get cosine squared A by itself. So 2 cosine squared A is equal to cosine 2A plus 1. And then divide everything by 2. So we end up with cosine squared A equals 1 plus cosine 2A divided by 2. Now, you may be kind of lost in figuring out exactly what we're doing, but what we're trying to get is we need to get down to basically a sine of x and a cosine of x. And then if we can get down to sine of x and cosine x, then we can figure out what the half is. So there's one last step in both of these to get it down to just sine A and cosine A. And that is, if we have sine squared A, to get it to sine A, we're going to take the square root. And we're going to do the same thing on the other side. So we have sine squared A. So to get sine of A, we'll square root everything. And then we're going to do the same thing with cosine squared A. In order to get cosine A, we're going to square root everything. So now there's just one step left because we have to do half. And in order to do that, we're just going to plug in x over 2 for A, because that's the same as 1/2 x. So let A equal x over 2. And if we plug that in, the sine of x over 2 is going to be equal to 1 minus cosine of x, because when we plug in x over 2 for A, those 2's are going to cancel and you're just going to be left with x. And that's all over 2. So there's our identity for sine of x over 2. Now we're going to do the same thing for cosine. If we plug in x over 2 for A, so we'll have x over 2 for A, then we end up with the square root of 1 plus cosine of x all over 2.